derived quantities. Derived quantities are dependent on other quantities and are defined by other quantities. They can also be obtained by simple combination of the other quantities. So why fundamental quantities cannot be obtained by what now? Combination of other quantities, derived quantities can be. So I will try something very quickly. I just hope you can tag along. Let's do this. Okay. Alright. So, for example, if I'm doing area is given as length times length. And please let me emphasize. In physics, when we're talking about length, length has to do with what now? Any space, line space between one point to another. So anything that you measure in that regard is termed as length under measurement. For example, if I move from here to town, I have covered what now? A particular what now? 9 seconds. It's not necessarily a straight line, all that. So distance is an example of length. The radius of a cycle is an example of length. Height is an example of length. Depth. Understand that the difference between height and depth is that for one you're measuring from bottom upwards, for the other you're measuring upward now, downward. So height and depth can be the same thing. The only difference is that one you're measuring from bottom to the top, that's height. If you're measuring from top to the bottom is what now? Depth. For any particular object, for any particular thing, the height and depth should be what now? The same. Alright? So there are other distances like circumferences. Perimeter. All of those are what now? They are lengths. They are all different. Even thickness. Thickness, because you encounter all these things. Width or breadth. The breadth or width. All of these are classified under length. So anytime you're looking for area, it's always two of these different lengths that you must combine. You must combine two of them to get what now? Area. So for area is always a combination of two lengths. Area is always a combination of two lengths. So I have length times length, and that is why the unit is also what now going to be meter times meter, which is going to give me what? Meter squared. The unit for length is meter. So since I'm having two lengths multiplying each other, meter times meter will give me what now? Meter squared. So the unit for area is what? It's meter squared. Another thing that we will have, another quantity right now, is volume. Any volume at all that you're dealing with has to do with what now? Three lengths multiplying each other. You already know the unit, I guess. Length times length times length means what now? Meter, meter, meter. So give me what now? Meter cube. The unit for the volume is going to be meter cube. Then if I have velocity, velocity or what now? Or speed. If I have speed or velocity, I want to emphasize as I'm doing this. What is speed? Speed is what now? The rate of change of distance with time. The rate of change of distance with time. What is velocity? Velocity is the rate of change of displacement with time. The rate of change of displacement with time, velocity. Rate of change of distance with time is speed. What's the difference? This is scalar, doesn't have direction. So speed is a scalar quantity. The vector for speed is called what now? It's called velocity. Because displacement has to do with distance, very and distance. If I say I travel 40 kilometers, that's distance. If I say I travel 40 kilometers due west, I get direction. That is what now? Displacement. If I say I traveled 5 meters to the staff office, is what now? Is displacement, because I'm giving what? Direction. For displacement, there's direction. For distance, there's no what now? No direction. But both of them have the same what now unit, because the unit of distance is meter And the unit of displacement is also what now? Meter. Because displacement is distance with direction. So displacement is a kind of distance, just as velocity is a kind of what now? Of speed. I'm sure you're getting all of this. Let's go further as quickly as possible. So if what I just showed you is true, it means that what? Both speed and velocity should have the same what now? The same unit. Which is going to be what? You're having distance, which is length over what? Over time. Length over what? Over time. If I have length over time, length is meter times what? Seconds. Meaning that the unit is going to be what now? Meter per second. Or if you want to write it the other way, for those of you that have done indices, I can write meter per second like this. They are both the same. Meter per second, meter per second. So the unit for velocity or unit for speed is going to be what? Meters per second. And I say you can write it like this also. It doesn't stop it. Alright? The next thing I'm going to talk about is what? Is acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. The rate of change of velocity with time is acceleration. Velocity with time, acceleration. Now what is the velocity is? Velocity is length over time. So if I have length over time, and then I have another time again dividing, length over time, this is already what now? Velocity. Length over time, meaning that I'm going to end up having length over time squared. Length over time, time times time. One time is already at the bottom, then I'm bringing time again. This is what? This is velocity. This one is velocity. Divide by what? Now by time. So at the end of the day, I'm going to have that what? That acceleration is length over what? Over time squared, which is going to give me what? Meter per second squared. Time squared, second squared, length meter. So I could write it as meter per second what now? Per second squared. It's all what now? All the same, all good. Okay, let me find a way to compress this a little bit. Because I really did it for some other explanation. I hope you can see that. Okay. Then if I go further, I could be doing something like density. Density is given as what? As mass divided by volume, or mass per unit volume. Mass over volume. That is density. Density is given as mass what now? Per unit volume. So what is the mass? Mass already says what? Kilogram, if you remember. From fundamental quantities, from fundamental quantities, we say mass is what? Kilogram. The unit of mass is kilogram. Unit of length is what now? Is mass. It's meter. And unit of time is what? It's second. So let's go back. Mass becomes what? Kilogram. Over what? Okay, sorry. Let me give you the dimension. Dimension, mass is capital letter M for dimensioning. Capital letter M. And then we're writing that volume is what? Length times length times length. That's what? Length to the power of 3. Length cube. So I end up getting what? Mass to be what? Mass is kilogram per meter cube. Kilogram for mass. Length cube is meter what now? Meter cube. This is the unit for what? For density. Mass over volume is density. The unit is what? Kilogram per meter cube. And then the dimension, which I'll talk about later, is M what now? L cube. M over L cube. So if I want to write dimension, I can write it like this. Or that. Okay. Then we have force.